Hello there, for this tutorial we look at how we can create a backend SQLite database that uses PHP for CRUD functionality. The SQLite extension should be activated for this to work properly. One does this in the PHP init file. For other databases like MySQL and MS SQL, the same process of activating the extensions is also needed. As you can see, the SQLite 3 extension is on. Let's also show how this is indicated in our Laragon development web server. We go to PHP, then extensions, and then the checked extensions are the ones that are active. After you have set the extension, it's time to indicate to the Banano library that it's using PHP. This needs to be done on the main module in the app start subroutine. First, for release mode where your app will run on an actual web server on the internet, the server IP should be updated to be your real web server. For example, if your web server domain is b4x.com, the actual domain being used to run the PHP scripts should be http://www.b4x.com. When the app is built, it will create a PHP file that will have all your PHP scripts defined. You will not be writing any PHP here for now. For database interactions, we use parameter queries. These expect data to meet 4 data types: text, integer, float and blob. So whatever we add should meet this criteria. We have written PHP scripts, a function called BananoSQLite, that runs our CRUD code. This returns an object with the affected rows of the query, an error, if any, the records array, so that we can process it further. We also need to create a SQLite database and add it as part of our files. For now we have created a database called test, with a single table called users. Let's look at the structure of this database. We have an auto increment field named ID, a name text field, and an age integer field. Our table is blank, but you can distribute databases that have content like this. We have already created a user interface to manage the CRUD functionality. We will explain this later. Let's open our Explorer page. We have buttons to add user, get users, delete, delete where, get with ID, etc. We are using a faker library to generate fake data for our name and age fields for each of the users. A fake user record is created each time we click Add User, and that record is added to the users table. When we click Get Users, a select statement is executed against the table. We also just ran a statement to retrieve all users that are aged 30 and above. Each user is assigned an auto-increment ID field. So when we get an ID equals to 1, we read the ID field that matches our crud with a select where clause. We also want to update a username where the ID equals 4. The name now has been changed to Alvarez. To do that, we ran an update where clause. Let's click delete to remove a user meeting an ID of 3 criteria. Now on the list of users, that user does not exist. That will delete all users where the age is less than 40. Delete all clears the table. We can also run additional calls to add more records, update them when a condition is met, delete some, etc., etc. In our code we created a container with buttons and some paragraphs that are bound to states. Each time a button is clicked, we execute the call against the table. The subroutine to add opens the database. The database is copied to the assets folder of our website. We specify the table to process, its primary and optionally its auto-increment field. It's important that we specify the table name each time we process commands against the database. This, however, is not necessary for execute commands. That was the database directly accessed from the publish location of our dev web server. We add users via our interface. The database is updated. So all command calls that are valid will be executed against the database tables. The primary key for our database is an integer and the name field is a text field. We need to tell our library this. Also, our age field is an integer. As an example, we create a fake record with an age and a name. We do not specify the ID field as the database will create its own. We then build the query command we will execute when calling insert1. We then call and execute our query by calling call inline PHP. This is an await JavaScript call that will wait until the process is complete. Whatever is then returned from calling the PHP function is then passed back to the app. To get all the users, we defined a sub and registered it. This runs a statement to select all users ordered by the name, then whatever is returned is saved to the records state. We specified a star for the fields because we want to select all fields. You could also just specify the fields to select as an array. Same applies to the sort order. When successful, a snack bar is shown. Let's look at the code to return all users meeting a particular age. We create a connection to the database. Our code tells us that the age is an integer field. We then feed it a map of the field we want and the value we want. We then specify that we want all fields to be returned, meeting that map clause, but now with operators. The operator here is greater than, for each of the where map values. We have one operator here because our where map object has only one key value. As soon as we run the command via the button click, our query string is built and executed. When we want to get a record using the primary key, a select where clause is executed behind the scenes. We specify the primary key type and then execute the read method. This builds our select where clause. Same with delete. We specify the primary key type and then execute the delete method, passing it the primary key value to delete. For updates, we need to feed our code, a map object containing only the fields and values that need to be updated. We want to update the name here using the primary key. We specify the field types. We create a record with a new name using the faker. We then call the update1 method, passing it the map object with the new details and also the primary key value to update. Let's look at deletes. We want to delete by field name ID. We set that as a primary key. We indicate its type, then we call the delete method passing it the value of our ID field. We can also define an expanded delete where clause. We feed this a map object with the field name and field value, and then the operators against that map object. Our operator here is less than, so we want age less than 40 here. So here we have looked at inserts, deletes, updated, select where, delete where to manipulate the data in our tables. One will learn soon enough that the code for the other databases we will discuss soon will be exactly the same, with the difference on configuration for the backend. All will use PHP. That concludes part 34 of our tutorial.